All right. Hello, fabulous intro micro students. This is going to be a lecture on elasticity. I apologize. I did these out of order. I did utility, which was chapter 6 first, and now I'm going back and doing chapter 5, which is elasticity. Both of these chapters relate to the theory of the consumer, understanding how consumers make decisions, how they choose how to spend their limited income, what to buy, right? So we go back to the fundamental issue in economics is that our wants are unlimited, but our resources are scarce. So how do we optimize? How do we make ourselves as happy as possible? Choose the combinations of goods and services that we can afford in order to make ourselves as happy as possible. So this is the elasticity chapter. And so what I've done is I have 3 handouts, which I have already posted in Canvas for you. One of them is the overriding notes from this chapter, is a summary of the chapter in my words, what I find to be the most important things to focus on when you're reading and studying chapter 5, and things I want to call your attention to. And then I've also posted 2 examples of exercises that we can work through, kind of working through the math, how to solve these problems of elasticity. This chapter is perhaps the most quantitative of the chapters that we have encountered so far. Marginal utility chapter does use a lot of math as well, quantifying marginal utility and then figuring out the budget constraint and things like that. So we are entering into the heart of micro, where we do use more quantitative analytical tools. So just a warning, this will continue, this level of math. All of it is basically high school algebra. It is not calculus based by any means. So this is stuff you should have seen in a high school algebra or earlier. Even what I like to say, I had an 8th grade algebra. So, however, for some of us, 8th grade algebra may have been a while ago, and you may need to brush up. If you do need to brush up on the math, let me know. You may need to see a math tutor specifically. It's not necessarily my job to teach you math, but I can certainly show you some tools how I solve the math problems. But if you're struggling with the math, you may need more help than I can offer. I'm not a math, I don't have my PhD in math. I have my PhD in economics. And although I'm very well versed in the language of math, I'm literate with respect to math. That's not my expertise, is teaching math. So, but by all means, reach out, find those tutors, find those resources that will help you get through this material as much as possible in an efficient way. I know there's a lot going on this quarter, but bear with us. Economics is a very analytical, very quantitative discipline, and I think you're going to start to see that. So hang on. And if you do have questions, reach out to me. And if I can't help you, I will certainly be forthcoming and say that. I'll say, you know what, let me see if I can find you a math tutor, okay? There's a lot of math I can do, and I will be able to help you with. So I shouldn't discount my talents in that way. But all right, so let me pull up. I'm going to share my screen here. This is Zoom again. So bear with me as I navigate and share screen. I'm going to pull up, I believe, what it's called is the Elasticity Lecture handout. And this is posted in Canvas for you. I'm going to leave my little video up here of me talking to you as I walk through this. This is a Word document, and basically what I've done is I've basically outlined the chapter, the most important things, and I've organized the information. The chapter is a lot of words, a lot of stuff coming at you. This is a little bit more succinct summary of elasticity and why it's important, okay? So let's start out with the general definition of elasticity, starting out right here at the top. Elasticities in general, we use them for a lot of things in economics, and not just microeconomics, not just intro micro. You go on to intermediate micro theory, which is really, really cool. If you're enjoying this class, I strongly encourage you to follow up and take the intermediate version of this, where we do dig into a little bit more of the quantitative aspects. We go behind the scenes of the demand curve, which can be really enlightening, I think, and really help you if you are thinking of being an entrepreneur, running your own business. That intermediate micro might be really helpful. But anyways, elasticity in general, in the general sense, elastic, like a rubber band. We're looking at if we stretch it, what happens, okay? So it's the responsiveness of one variable to a change in another variable. If I change X, what happens to Y? So in this case, some examples in economics, especially this intro level economics that we do, is how might consumers respond to a change in price of a good or service? If we change the price a little, what's going to happen? Are our customers going to abandon us, or are they just going to go, whatever, and pay it? Okay. So we need to know if we change the price, for example, we raise the price, are our consumers going to fall out of the market entirely, or are they just going to go, we'll tolerate it? Okay. So will the quantity change a little or a lot? So that's the price elasticity of demand. Another question that has to deal with elasticities is, how do consumers change their purchases when your income changes? So when your income changes, do you buy more or less, a lot more or a lot less, or just the same amount? So we look at goods and we say, okay, what's the responsiveness as people's income changes? How do they respond with respect to their purchases of certain goods and services? And that would be the income elasticity. Third is this: how might consumers of one good change in response to the change in the price of another good, a related good? So, for example, if we have a change in the price of strawberries, what would happen in the grapes market? Are they closely related? Are they not related? Are they, somewhat related? And so that responsiveness, if strawberries are on sale, do we totally switch and not buy grapes at all? Do we still buy some grapes? So what does that response look like? How responsive are we in the grape market in response to a change in the strawberry market? And that's our complements and substitutes. And then lastly, as a firm, if the price changes, how do we respond? For example, let's say we're a farmer and we're growing wheat, but we notice that the price of lentils is going up a lot. Do we switch? Because it's pretty easy to switch your field over from wheat to lentils. Similar conditions for growing those things. We grow a lot of those in Eastern Washington. So it'd be pretty simple to just plant lentils instead of wheat. And so in response to a price change, if lentils are taking off and the price of lentils is going through the roof, it would make sense for a firm. To what extent do they respond by kicking up their production of lentils, for example? And so that's what the price elasticity of supply looks at. So why is this important? Why do we care about elasticities? Well, for a firm, you want to know how people are going to respond. If you're considering either raising or lowering price, you want to know what's going to happen. Is that a good idea? Is that you're sitting around the board of directors table and you're all having a conversation? Okay, we need to increase revenues. What is the best way to do that? And somebody pipes up and says, oh, I know, if we lower the price, people will buy more, we can sell more. And then someone else goes, well, if we raise the price, we've got really loyal customers. We may not lose that many, but the rest of them, we can charge a higher price. We might get more revenues that way. So it really depends on how responsive your customers are, and in fact, how loyal they are to your product. So having a sense of the elasticity for your product is really important for making these decisions about maximizing revenues, okay, and profit altogether, okay? As a firm, you also need to know how you're going to respond to changes in the price of your good or service. How much are you going to amp up your production when the price goes up? How much are you going to cut back when the price falls and you can't afford to produce as much as before? And so that elasticity of supply is really important for a firm to understand, like a farmer, for example. So things to look for in this chapter. Again, this is just an overview of chapter 5. Make sure that you're following along in chapter 5, right? And so one thing we're going to do is this quantitative stuff. We're going to learn how to calculate various elasticities. And there's two approaches. One is the general formula. And the general formula says that elasticity is the percentage change in quantity divided by the percentage change in price. So by how much does the quantity change when there is a given percentage change in price? You would use the general form if you do not have the specific prices and quantities to use the midpoint formula. The midpoint or arc elasticity formula, as presented in your chapter, is the preferred method. This method is insensitive to the direction, if you're increasing or if you're decreasing the price. It does matter in terms of percentage change, but if we average it between the 2 points, then we take away the directionality. And so the midpoint formula is a little bit more precision, and it gives us more of a decision between 2 points. What is the elasticity? So we prefer to use the midpoint formula. You should always try to use the midpoint formula first. If you can't, if you're missing a price, missing a quantity, you don't have enough information, then you default to the general formula. It should not be that you jump to the general formula first, okay? because you can use the general formula when you have the P's and the Q's, but it's less precise. All right. So that being said, always look to use the midpoint formula. We'll give you some practice with that, and then we'll give you some practice with the general formula when you may not have all the information available with incomplete information. You can use that general formula. All right. In addition to being able to calculate various elasticities, and there's 4 different types that we're going to be looking at, and that is the price elasticity of demand, cross-price elasticity, income elasticity, and the elasticity of supply. So you need to calculate all of them. However, the good news is the formula is basically the same. So you don't need to write out all the formulas 4 different times. You just need to know the general shape of the formula and how to use the formula. By practicing it enough, you'll become really fluent in it. In addition to all of that, the calculations aside, we need to understand the differences between the 4 major types of elasticities, how they differ, what they measure, what they tell us about a market and about the consumers in that market, or the firms if we're talking about elasticity of supply. Third is, how does this elasticity of demand relate to total revenues? Because total revenues is one of the things that drives profit. Profit is equal to total revenues minus total cost. So increasing those total revenues as much as possible can really help us as one option for increasing our total profit. So knowing the connection, if I understand elasticity of demand, then I have a sense how that relates to total revenues and how that can increase my profit down the road. So that's super important. Pay attention to that part in the chapter as well. And then lastly, how the demand curve itself as a graph relates to the total revenues curve. And we're going to do what's called a stacking, where we'll stack the 2 graphs on top of each other so that the horizontal axis remains the same in both cases. And then you can compare them, because the horizontal axis will be the same. The vertical axis will be different between the 2 graphs, but you can still look at the 2 graphs and see similarities between them and how portions of the demand curve relate to different portions of that total revenues curve. And it's really insightful, I think, really making that connection, that the demand curve really tells us about what we can and what we should charge with respect to our customers. So those are things, the highlights that I want you to, if you didn't catch that the first time when you were reading chapter 5, to go back and look for those things in particular in chapter 5. All right, so moving on, let me talk about behind the scenes. So this is what I do on the whiteboard. I apologize, it's a much smaller whiteboard than I'm used to. I had to do this on my iPad. So trying to do this all really small, when in fact I take up half a whiteboard in class. You can imagine a big whiteboard in the front of the classroom, right? But I like to motivate this in showing how elasticity of demand helps us to understand responsiveness. And so what I've done is I've drawn 3 different demand curves. In this case, 3 slightly different demand. They're all demand curves. They're all downward sloping relationships between the price of the good and the quantity that would be demanded at those various prices. And so if you look at these 3, on the left, the demand curve is relatively steep. In the middle, I tried to make it flatter. And in the third, I tried to make it somewhere in between. Not too steep, not too flat, right? Okay. It's like the 3 little pigs. And we use that analogy in economics probably more than we should. Oh, the interest rate is too high, too low, just right. So we use that analysis a lot. We call it the 3 little pigs. Anyways, Goldilocks and the 3 little pigs. Not the 3 little pigs, I'm sorry. Yeah. Anyways, the 3 little bears, right? Goldilocks and the bears, right? Mama bear, Papa bear, and baby bear. I had my fairy tales mixed up there. I apologize. The 3 little pigs is the brick and the stone and the wood, the houses. Anyways, you get the idea. So there's the mama bear, the papa bear, and the baby bear, right? Anyways, so it's the Goldilocks rule, and the 3 bears. So here is the elastic, where it's really steep, flat, or no, inelastic, I'm sorry, is really steep, elastic is flat, and unitary is somewhere in between. What I've done is I've started them all at P1. There's arbitrary P1 shown by this red dotted line. Look, it equates, go all the way across all 3 of them, and you can see that they all line up. What I'm going to do is I'm going to drop the price by the same amount in all 3 markets. And think of this as a percentage change, not necessarily a dollar change, but let's say, and I have it written here, this is a 10% reduction. So let's say we're taking it from $100 down to 90, okay? It's the price of a bicycle or something. We're going from $100 down to 90. It's a 10% reduction. In all three markets, it's the same percentage change in price. And what we want to see is, knowing the law of demand, that when the price falls, the quantity demanded moving along the demand curve, notice new demand curves moved, right? Price change only. Going back to that supply and demand. In this case, in response to the 10% reduction in the price, the quantities changed by different amounts depending on the shape, the relative shape of the demand curve. They have the same shape. They're all downward sloping and they're all linear, but they have different levels of steepness. Their slopes are different. I'm going to caution you, slope is not elasticity. I'm going to show you that on the next page in just a second. But by looking at the relative steepness and the relative flatness, we can make some conclusions that the one that's steeper is more inelastic, the one that's flatter is more elastic, and the one in between is very likely to be unitary. Okay, so what does that mean? So look at the inelastic one. I dropped the price 10%. See that green arrow? Okay. But my quantity didn't increase by the same amount. It only increased a little. Let's say a little means, let's say 5%. So in this case, look at my blue here. The percentage change in the quantity, 5% in yellow here, is in fact less than the 10% that was my percentage change in price. So I lowered my price, but my quantity only went up slightly, not as much. So it's inelastic. It didn't respond a lot. Elastic is really stretchy, really responsive. Inelastic, not so responsive. Okay? Look here in the middle now, talking about that elastic, very responsive. In this case, in this market, with this flatter demand curve, I lower the price 10% and my quantity increases by a much bigger, look how much bigger that green arrow is going horizontally than it is coming down vertically, representing the 10%. So if this arrow from P1 to P2 represents 10%, this bigger arrow I hypothesized represents about 25%. So change the price a little and my customers go crazy, right? 25%, okay? So in this case, look at my blue and my yellow here. The percentage change in quantity, the 25% increase in quantity, was greater than the 10% reduction. And what I'm saying here, and I did not make the notation on here, I should have in hindsight now that I'm thinking about it. We're talking about absolute value. We're talking about the magnitude of the shift, not the direction. Because truly, in each case, my percentage change in price is negative. It's negative 10. So my percentage change in quantity, obviously in all three cases, would be greater if we were just looking at the negative 10 versus a positive quantity, right? But what we're talking about is the absolute value, just the magnitude. Don't look at the sign in this case. And that's something we do in economics a little bit. It's just we care about the magnitude of the response. So in this case, when I have this 10% here, that's actually, I should have put absolute value signs around these to be a little more technical, but sometimes I found that intro students don't necessarily understand what those absolute value signs mean. But hopefully you remember absolute value, you just take the positive value of whatever's inside the brackets, okay? Whatever we're taking the absolute value of, we disregard the sign and we're just looking at the magnitude of the change. All right. Over here on the unitary side, we're looking at a decrease in 10% in price. It's offset exactly by an increase in 10% point. So this arrow coming down is the same size as this arrow going to the right. Two green arrows cancel out. 10% is equal to 10%, and that's called unitary, when the response in quantity is of the same magnitude as the response in price, not taking into account direction, just the magnitude, okay? And so that's the idea, that depending on the shape of these demand curves, we can get a sense of some markets are going to be a little more responsive. Some markets are going to be a little less responsive. All right, so let's go down, next page. Although this relative slope, steep, flat, neutral, tells us about the elasticity of demand, I do want to point out 2 words of caution, that the elasticity along a linear demand curve actually changes. We have an example of this we're going to work through, so that when you look at a linear demand curve, the elasticity is not constant. And it actually changes in a systematic way, and we're going to work through an example, practice using that midpoint arc elasticity formula, and prove this. So that's one thing. So you can't say that, you know, one curve is more elastic or inelastic than the other, because they both have elastic portions, they both have unitary portions, and they both will have inelastic portions, okay? Additionally, elasticity is not slope directly, because if you look at the midpoint formula, and this was presented in the book, it was presented in a slightly different way. I've manipulated the algebra. It's still the same. You can go and check. You can rewrite what I have here and derive what's in the book. I find this an easier way, I think, for intro students to think about the elasticity formula. And so what we're doing in my elasticity of demand midpoint formula is we're taking the change in Q divided by the change in P and multiplying it by another fraction that is created from average price divided by average quantity. And over here, I have the definition written out for you of what the change in Q. Oh, by the way, this delta, this is the Greek letter delta. It's not just a triangle. That's the Greek letter delta, and it means change in sciences and in economics. So change in Q over change in P, and then the bar over means average, average P divided by average Q. So change in Q is just the difference between your two Q values. Change in P is the difference between the two P values, making sure to keep, if PT, make sure that P2 is associated with Q2 and that P1 is associated with Q1. It doesn't matter which one you choose, except that they have to be paired together, okay? And then average P is take the two prices, add them together, divide by 2. Average Q, take the two quantities and divide them by 2. I always say just go between them, okay? Halfway between the two values is, anyways. But when you look at this formula, this entire formula here, okay, what I want to point out is this first term, change in Q over change in price. This is actually inverse slope, because when you plot the demand curve, and look what I've done here, I've plotted a demand curve and I've pointed out a P1 and a Q1, and notice this is what I was saying about them being paired, right? P1 goes with Q1 and P2 goes with Q2. I could have called the greens P1 and Q1, and I could have called the reds P2 and Q2, but they have to go with their buddy, okay? But anyways, with this downward sloping line, with P being on the vertical and Q being on the horizontal, the slope of this demand curve would be, as you recall, and I always remember my 6th grade algebra teacher, pre-algebra teacher in 6th grade, beat it into my head that slope is always rise over run, go up and go over, right? So rise over run, well, rise is the P and run is the Q. So in this case, the slope of this demand curve, technically speaking, would be change in P over change in Q. And if you look, the midpoint formula is the upside down, the inverse of that slope. So elasticity is similar to inverse slope. Now, this is a straight line, so this inverse slope will stay constant as you go along the demand curve and calculate various elasticities, right? Because the slope is constant, the inverse slope is also constant. So let's say if the slope was 3, the inverse slope would be 1/3, and whether it's 3 or 1/3, it's still going to be constant. However, elasticity of demand, if you look at the rest of the equation, is not just the inverse slope. It is the inverse slope multiplied by the ratio of the average price over the average quantity. And so basically what this is, if you're thinking about those calculus people out there, this is the slope of the line evaluated at the midpoint between those points. So this is evaluated at the midpoint. That's what that means. But for each set of points, P1, P2, Q1, Q2, P2, or P3, Q3, P4, Q4, we're going to change the average P and the average Q. So you can see then that the elasticity of demand is going to change as the average P and the average Q change, okay? And so that's what we mean, that the elasticity along a linear demand curve is going to change, even though this inverse slope part won't change. This part does change as we go up or down the demand curve. So keep that in mind. So elasticity is not slope, although it's closely related to the inverse slope, it is not, okay? All right, so going on, some comments that I want to make in particular about the price elasticity of demand, right? And we want to know, if we raise the price, what's going to happen to our sales, okay? So one, when we do this math, when we do this change in Q over change in P, because of the law of demand, let's look at it on this graph here. As the price is falling, my change in P is negative, my quantity is increasing. My change in Q would be positive. So because there's this inverse relationship that when price falls, quantity goes up, elasticity of demand will always be negative. It'll either be positive over negative or negative over positive. Either way, it's going to end up negative. So the calculation itself is always negative. But by convention, we typically just refer to the absolute value, the magnitude, how big, how responsive, right? And so we often talk in the absolute value sense. We often will drop that negative. It's like we get lazy, but we all understand it's implied that of course elasticity of demand is negative. So we don't need to say it necessarily all the time. But be really careful when you're reading questions and make sure that there's a negative sign. When you're doing calculations, you absolutely want to put those negative signs in there. It will change your calculations and your interpretation. So remember, elasticity of demand are always negative when you're working with the math. When talking about it, it is okay to not have to say negative all the time. All right. When we're interpreting elasticity of demand, we're talking about the different degrees. When I put those labels on the graphs, inelastic, elastic, and unitary, I was identifying a label with a particular range of values that the elasticity of demand measure will take. Now remember, the elasticity of demand measure itself does not have units, okay? The two percentages in the top and the bottom will cancel out, and there's no units in this, okay? So elasticity of demand is just a number. Its elasticity of demand is negative 3.6, okay? Elasticity of demand is negative 0.5. Do not put percentages on there. Do not put units. Do not put dollars on it, all right? It's just a number. And so when we look at that number, we want to put that number on a scale on the basis of the number that we calculated and give it a name. And so that's how we interpret the elasticity of demand. So if the absolute value, again, because it's negative, we're just looking at the magnitude. If the absolute value of the elasticity of demand is greater than 1, if it's 2, 5, 25, 200, okay, the demand is called elastic, meaning that the consumers are very responsive. On the other hand, if you do the elasticity of demand calculation and you get a decimal, if you get 0.5, 0.75, 0.03, okay, then the demand is inelastic and you're facing a demand where your consumers are not that responsive. Inelastic. If the absolute value comes out exactly equal to 1 or somewhere like 0.99 to 1.01, something really close to 1, it rounds to 1. In that case, the demand is what we call unitary. So unitary elastic, meaning that it's in the middle, that my consumers will respond to a change in price by a quantity change that is the exact magnitude as the price change. All right. And so that's what you say. When I ask you on a quiz or a homework or an exam to interpret, you're going to say elastic, inelastic, or unitary when we're talking about demand and supply. You will not use those terms to describe cross price or income. So keep that in mind. These are only labels that apply to the elasticity of demand and the elasticity of supply. Cost price and income have their own labels that we're going to use, and I'm going to present them here in the handout in just a minute. All right. So then the question becomes, thinking about those three different demand curves that I drew for the inelastic, elastic, and unitary, what are some real world examples, right? What kind of goods and services does that inelastic demand curve relate to? Where would it be the case where we would see a steeper or a more inelastic demand? And some examples of markets that have a lot of really inelastic demand are addictions, things that are necessities. So you can raise the price and consumers will pay it anyway. This is what we're seeing with our addictions, whether it be to a prescription drug or to a recreational drug, meth or cocaine or something like that, or cigarettes are pretty addictive, we're seeing. And so in those cases, you can raise the price, and some people might fall on the market because they just can't afford it, but most people will say, oh my gosh, I just have to pay it, and they'll find a way, okay? Gasoline. A lot of people think, oh, I need to put gas in the car, I need to get to work, right? And so therefore it's a necessity. Well, in the short run, absolutely, okay? So you get up in the morning, you go out to start your car, and it's on E. Absolutely. You're just gonna go to the first gas station you find, and you're gonna fill up your tank. But what we've seen, interestingly, with gasoline is if it reaches a certain price, like over $3 in Spokane, we're over $3 a gallon, there was a lot of substitution going on. Our STA bus ridership went through the roof when the gasoline prices were over $3. People were making substitutions. They were driving their cars less, putting less gas in the car, and using their bicycles or walking or running or carpooling or taking the bus, finding alternate ways to get to work. So in the short run, gasoline is absolutely inelastic, right? You're driving on the highway, you got to get home, you just have to hit this last exit to make sure that you can make it the last 50 miles to get home. Of course, you're going to pull over and fill up your tank, right? But if you have time to plan, you're going to react to an increase in the price of gasoline and say, I'm going to see if my neighbor is willing to set up a carpool. Let me see how much it costs to ride the bus. I'm going to start riding the bus for a little bit till those gas prices come back down into a more reasonable range. So in the long run, it's interesting that gasoline is actually closer to unitary in the long run. All right. So anyways, Wi-Fi, if all of our classes are online this quarter, you got to have the Wi-Fi. That's an absolute necessity. So things like that, utilities are definitely going to be inelastic demand, things that we deem as necessities. Also, things that you don't look at the price of, you just throw them in your cart and buy them anyway. Things that are so small, like toothpicks or a pack of gum. You're standing in line to check out, and you're ready to check out with, your $100 of groceries, and you see the pack of gum or Tic Tacs. You're like, oh, just throw them on the pile. Who cares? You don't even look at the price, did you? Right? You don't care if the price goes up 5 cents on your pack of Tic Tacs. You're just gonna throw it on the cart. What's an extra 5 cents on your $100 bill of groceries anyway? So, and then lastly, things that have more inelastic demand are items that lack substitutes. So, for example, if a pharmaceutical company comes out with a brand new drug, we are now seeing that there's a new drug coming out for COVID-19 in particular. While that is under patent, nobody else can make or manufacture or distribute that drug. So that firm knows that you have to buy the product from them. They can charge more. Okay, they can raise their price. You don't have an alternative. You need that medication to live. You're going to pay it. Okay. So in some cases, items like that lack substitutes, where there's a monopoly, you will see more inelastic demand for those products, but not always. Okay. Elastic demand, on the other hand, thinking about whereas this was items that you need, the other end of the spectrum, the other extreme is things that you don't need, things that are luxuries. And whereas the inelastic demand had our small ticket items, a small pack of gum, toothpicks, our elastic demand is our big ticket items. You're going to see yachts, big vacations, a new house. Any type of big ticket item is going to be elastic. Items with a lot of substitutes it's going to be elastic, because if one competitor changes their price, you can always go to one of the hundreds of other competitors to get your product. Okay. So an example of an item with a lot of substance is a 16-ounce caramel latte. You could get a 12-ounce, you could get a 20-ounce. You could change it from a caramel latte to an espresso or to a frappuccino or whatever, however you like your coffee, right? So there's a whole bunch of substitutes for a 16-ounce caramel latte. And concert tickets, right? Those aren't necessarily essentials, necessities. They're fun, but if the price of the concert ticket got too high, you just go, I'll pass on this one. I'll go to the next one. Okay. Unitary demand, it's somewhere in between. And there's not a lot that actually hit that 1.0. Most of our goods are slightly above 1 or slightly below 1. But some good examples of the unitary demand is our fresh produce. So fresh green beans. We do have frozen green beans that some people buy. Or, for example, fresh corn in the summer, corn on the cob, as opposed to canned corn. So our fresh produce tends to be unitary, where people are like, I'd love to have the fresh. If it gets too expensive, I'll just buy the frozen or the canned. Movie theater tickets nowadays, we're noticing that people are like, I can wait for it to come out on DVD. I can get it from Redbox. I can stream it. And so movie theater tickets, they're kind of like take it or leave it. I want to go, but if the price gets too high, I'm not going to go. So those are more like unitary demand. So to summarize, in describing the different types of markets that fall under the categories, you can make some general conclusions about factors that make a good or service more or less elastic. One of them is that availability of substitutes. So the more substitutes, it's going to be more elastic. Additionally, if you have more time to make a decision, then it's going to be more elastic. You're going to shop around. So think about airline travel is interesting. If your great uncle dies or your grandma dies and you have to get to the funeral, it just happened and you can't wait, you're going to book a flight for 3 days from now, you're going to pay a lot more than if you know, oh, okay, 6 months from now, we're going to take the whole family to Disney World, and you're going to comparison shop and you may be able to get a better price 6 months out. So the amount of time to make the decision, more time, more elastic. You're more sensitive to price. You're going to shop around for price a little bit more. An amount of the budget that your purchase comprises. So if it's a big ticket item, you're going to shop around. You're going to shop around for that perhaps engagement ring for your loved one. Make sure that you get the right one, right? Because it's a big purchase, the first house, or the big trip that you're going to take. Big ticket items, right, make up a big amount of your budget. You're going to be more price sensitive. A new car. Hopefully you don't just drive to the lot and pick out the first car you like and take it, right? You're going to compare cars, go to maybe some different dealers, look around, do some shopping, shop online, right? All of that because it makes up more of your budget. So you're more price sensitive. You're more elastic for those big ticket items. Also, how we define the market really matters. And we can define as economists markets very differently. Notice what I did with the 16-ounce caramel latte, right? I didn't say all coffee drinks, right? In this case, think about the demand for a 16-ounce plastic bottle of Diet Coke. Okay, the demand for that and the availability of substitutes, right? Where there's tons of them. You could get a can of Diet Coke. You could get a liter bottle. You could get regular Coke. You could get other cola. You could even get Gatorade or water or juice or all those things, right? Lots and lots of substitutes to a 16-ounce plastic bottle of Diet Coke. When the market is very narrowly defined, very specific, 16-ounce plastic bottle Diet Coke, then the demand is elastic, tons of substitutes. On the other hand, if I define the market as all beverages, there's no substitutes for beverages. We need water to survive, right? So that's clearly a necessity. Water is in beverages, okay? So the demand for beverages is inelastic as can be, because you're going to die if you don't drink a beverage. Does that make sense? So hopefully I'm asking you and you can't respond. But in this case, so the more broad, the more inclusive, once we've absorbed all of those substitutes into our market definition, all beverages, there's no more substitutes. That's a monopoly. So that's inelastic. Broad definition of the market, inelastic, small elasticity number, it's a decimal. People have a hard time because it's opposite. You want to go narrow is small. No, narrow, big number, broad, small number when we're talking about elasticity. Okay, so a narrowly defined market is more elastic. Necessity versus luxury. Luxury, obviously more elastic. Necessity is more inelastic. We talked about that. Lastly, I think this is last. Oh no, a little bit more. Okay. Next, what I want to talk about is the relationship of demand and total revenues. So I drew the downward sloping demand curve, and where I've mentioned that, hinted at before, is that the elasticity varies as I change my P's and Q's and I go along this demand curve. My elasticity of demand is going to change from being more elastic when the price is high to being less elastic, more inelastic when the prices are low. And it will pass through a unitary elastic point. All linear demand curves have these three parts to them. And in fact, that relates to the total revenues curve. And the total revenues curve looks like this. So that if costs weren't a factor, where the firm would choose to reduce is maximum revenues, right? And that would be at the unitary elastic point. So when I often hear people say, oh, firms can charge whatever price they want. Well, yeah, firms can charge anywhere along this demand curve. Are they going to charge way up here? No, they're not going to charge way down here when their revenues are too low. That's ridiculous. That's stupid. Stupidest thing I ever heard, right? Firms are going to charge somewhere near this unitary elastic point, somewhere in this middle here, right? Not too high, not too low, right? Just right, the just right Goldilocks price. Okay, because that's where this total revenues curve reaches a maximum. Past this point, if we were to continue to lower our price in this inelastic region, we wouldn't get the uptick in quantity that we would desire. We'd only get a slight uptick in quantity and not enough to offset the decrease in price, and our revenues would fall. And so on this side, what you want to do, if you're on the right-hand side of this total revenue curve, is you want to go this way to get to the maximum. You want to raise price if you're inelastic. If you're on the left-hand side of this total revenue curve, before it hits the peak, right? Look at your demand curve. What you want to do is you want to lower price. You want to walk down this demand curve to get to that unitary point. So the best point, again, we're not taking into account cost yet. There's more to profit. There's the whole cost story. But just looking at maximization of revenues, right? You want to get to that unitary elastic point if possible, because that's at the top of the total revenues. So if it's elastic, lower price, inelastic, increase price, and you'll end up right here at this red dot in the middle where it says unitary elastic. So if you are a firm, you have fabulous economists working for you, and they say, hey, we've got our estimates of demand for this product line and it's elastic, then you go, bingo, thank you, I'm lowering price. If they come back and they say, hey, good news, our demand is inelastic, then you go, hey, jack that price up, baby, right? And you can increase price. If they come back and say, you know what, we're pretty much at the unitary point, then you're going to say, hey, hold tight, we're doing good, right? There's nothing you can do. And by trying to change the price, you actually incur the price of all the price changes. Having to have someone go out on the shelf and change all the labels, or having to change it in the computer. That's time, it's unnecessary. For what gain? You're not going to have any gain, right? So it's not worth it. Okay. And so here is just my graphical representation of all of that. So if you think about total revenues is actually price times quantity. It's how many goods did you sell times what prices did you sell them at, okay? And so I also have, if you know the derivative, you take the total derivative with respect to the two variables, price and quantity. It has to be a total differential. Can't do in this case because you've got the two variables changing instead of just one, right? The P and the Q. But anyways, those of you that know calculus would know that. And this is derived from calculus. The rest of you just know this is the rule, right? You don't have to understand where it came from. But the percentage change in total revenues is actually equal to the percentage change in price plus the percentage change in quantity. So thinking about if we're faced with elastic demand in this first scenario here, and we were to raise price 5%, my quantity would fall because it's elastic, my quantity would fall by more. So my quantity would drop by 10, 5 minus 10, and that's a -5. That is bad news for total revenue. On the other hand, if I lowered my price, and let's say I only lowered it 3%, my demand, or my quantity demanded, not demand, quantity demanded went up by 10%. The net effect, 10 minus 3, is 7 in the positive direction. So lowering price when demand is elastic will increase my total revenues. Use this formula to figure out how much, okay? So good idea. Elastic demand, lower price. Let's look at the next one. In this case, if we have inelastic demand, our consumers are not as responsive. So in this case, if I lower my price 5%, -5, my quantity only goes up a little. Notice that little teeny green arrow right there. Only goes up 2. The net effect, -5 plus 2, is -3. That's not a good idea. My revenues are going down. The boss would fire me. On the other hand, if we're faced with inelastic demand, I raise price 10%, little change in quantity, it only falls by 2%. My net effect is, hey, I just drove total revenues up 8% and I get a promotion. My boss loves me. On the other hand, if it's the third case where it's unitary elastic demand, raise my price 10%, my quantity falls exactly 10, no change, don't do it, stay put. So that's just the little bit more illustration of what's going on behind the decision-making rule when you know your elasticity, how you respond as a firm. All right, the other types of elasticities that are dealt with in this chapter, one of them is the cross-price elasticity. And for the cross-price elasticity, in this case, you do the math, you use that midpoint formula, you come out with a cross-price elasticity that is positive. Okay, it's greater than 0. So in this case, the positives and the negatives are absolutely important when you're putting them into the formula. Okay, if it comes out positive, greater than 0, the goods are substitutes. A change in the price of X is going to increase the quantity of Y, right? On the other hand, if that cross price elasticity, you put the numbers in, crunch it out, and you get a negative sign in front of your cross price elasticity, then we know that the goods are complements. An increase in the price of X is going to cause the quantity of Y to go down. That's the bagels and cream cheese. You raise the price of bagels, and nobody needs the cream cheese to go with it. Those are complements. On the other hand, you do the math and you find out that the cross price elasticity is 0. Those goods aren't related. You're looking at a change in the price of hot dogs to the quantity of automobile tires, right? They're not related. So in that case, it just comes out as a 0. Additionally, we can also look at the magnitude. How closely related are the goods? Are they strong substitutes or weak substitutes? Strong complements or weak complements? So we can add an extra adjective, okay? Adverb, because we're describing an adjective. Anyways, so we're no, because that's noun. We're describing an adjective. Go back to my grammar. I'm not an English major, but we're adding the adjective strong or weak to the noun substitute or complement, okay? So in this case, if the absolute value is greater than 1, the magnitude is bigger than 1, 3.6, 10.8, 15, those are strong relationships. Change in the price of one good causes a big reaction in the other market, okay? So in that case, it's either a strong substitute or a strong complement because you're taking the absolute value. Doesn't matter if it was positive 10 or negative 10, okay? The magnitude is 10. All right. On the other hand, if the absolute value is small, if it's a decimal, if it ends up less than 1, 0.59, 0.37, negative 0.28, okay, those are all examples where the absolute value is a decimal, the magnitude is a decimal, less than 1, that's a weak relationship. It's going to change, but not by much. So we call those weak substitutes or weak complements. So an example, I said if the elasticity cross price is negative 3.5, what you would report is the goods are strong because the absolute value is greater than 1, 3.5 greater than 1, and they're complements because the sign is negative. It's negative, they're complements. So you would report strong complements and you would get all the points on that question. All right. Another type of elasticity that we look at is income elasticity. Income elasticity, by the way, let me go back to cross price for 1 second. Nowhere in here did I use the words elastic, inelastic, or unitary. Okay, so do not say that it was a unitary strong substitute. No such thing. Okay, or that it was an elastic substitute. No, we do not use those words when we're describing cross price. We use the words strong or weak, sub or comp. There's only 4 words you're allowed to use when you are interpreting cross price, okay? Students, sometimes they learn this new tool about elastic, inelastic, and unitary. They try to apply it everywhere. Does not apply to cross price. All right, so let me go. Same thing with income. Do not use the words income or inelastic, elastic, or unitary when describing income elasticities. We're simply looking at normal or inferior. If the income elasticity comes out to be positive, then that's a normal good. Income goes up, I buy more, normal good. If the elasticity of income comes out to be negative, my income goes up and I buy less ramen noodles, that's an inferior good. If my income goes up and I don't change my consumption at all, then that good is income insensitive, okay? And so those are your only 3 options. Nowhere in this interpretation of income elasticity do you see the words unitary, inelastic, or elastic. However, the words elastic, inelastic, and unitary absolutely apply to our last measure of elasticity, the elasticity of supply. So you do your calculations, you do your midpoint formula for your elasticity of supply, and you find out that the number comes out greater than 1. Elasticity of supply, the numbers are always going to be positive, whereas the demand curve was downward sloping, negative relationship between the price and the quantity. In supply, the supply curve is upward sloping. It has a positive slope. So when the price goes up, firms provide more. So elasticity of supplies will always be positive. So we don't need to worry about those pesky negatives. We can always just talk about them in the absolute value or positive sense. And so if the elasticity of supply is greater than 1, it's elastic. If the elasticity of supply is less than 1, between 1 and 0, it can come out to be inelastic if it's a decimal. If it comes out to be exactly 1.0, then it is unitary elastic. So the elastic, inelastic, and unitary apply to the elasticity of supply and the elasticity of demand. Income elasticity and cross-price elasticity have their own interpretations. And that's a review of the major content that is in Chapter 5. What I want to do next is I want to work through the 2 handouts that I have also posted. But I do need to take a break. I'm going to stop. This is getting a little long. Allow you guys to take a break as well. My little guy just came in here and wrote me a note, so I better go check and see what that's about. But anyways, I'm going to stop here. These are already posted, so I'm going to upload this video on the overview of the elasticity of chapter. And then the next lecture I'm going to post will be one of those 2 handouts. I forget which one I'm going to open up and do first, but I will do a short lecture, much shorter than this one, on the 2 handouts. You know, 1 lecture for 1 handout, 1 lecture for the other handout, so that you can process the stuff separately. You can rewind, go over it more slowly if you need time to do some of the calculations and so on. So, all right. Well, thanks for listening, and look forward to those other 2 lectures on elasticity as we do the math, as we work through the more quantitative aspects of calculating these various elasticity measures that we just talked about. All right, so I'm going to end the meeting here. Oops, nope. I'm going to stop share. I'm going to come back here and I'm going to hit pause. All right, so I will chat with you guys shortly.